here in this deployment, for example, here we have our access layer devices. We have here our distribution layer devices. Here we have our core layer devices. And these core layer switches are going towards two edge routers. One edge router might, lead us towards the known external network, such as data center headquarters, and one router might lead us towards a known external network, such as internet, cloud, public cloud. We have, like, for example, deployed our DNS center maybe right here. The DNS center could sit anywhere, like it could sit anywhere. The WLZ could sit anywhere. But like just for the representation purpose, we have deployed our wireless LAN controller here onto this switch. We have deployed our DNS center connected onto the switch. I can place it on here. I can place it on here. We have two routers here as well. These two routers are going to act as something called control plane node. We will just talk about that in a moment. From the SDA, so we have all our network. We can have like some just for the sake of wireless as well. Let me just quickly. Let's say for example, here we also have at the very edge. Let's say for example, we also have some access points, right? So on let's say for example, each switch, we also have some access points connected, and these access points that we have connected here, they are being managed by the wireless LAN controller that you can see right here in the picture. I'm not sure that if we have the option of the, I would say the extended node in this software packet tracer. We might not have any option of that, but you can consider that there are some extended nodes as well that is going towards, let's say, for example, the LAN network. Let me represent it with something like that. Where is that switch actually? Let me represent it with, we have it. Oh, here, IE, here. We have that. In this packet tracer software, we have this IE switch, that is labeled as this industrial Ethernet switches. So considering that we have somewhere like we have some non-carpeted environment in some place, we have like here, for example, this switch as well. And here then we can, here on this device, we have multiple boards, and here we can connect like a few devices as well, something like that. Okay. So the point is, like we have like different types of network in like we have wired, wireless, like we have like, mix of all that. We have all the devices, we have done all the cabling and everything. We have made sure that all the devices are reachable to all the devices. We have made sure that the reachability and everything is there. Once we have done the connection, once we have made the reachability, once every device is reachable to every device, once the devices are reachable to the DNS center and everything, once everything is there, now we are going to create our SDA fabric. And when it comes to creating the SDA fabric, we are going to set the roles on the devices. The SDA fabric will include some roles onto the devices. The SDA fabric will include some roles onto the devices. We are going to set total 3 roles onto the devices. We can set the role as fabric edge node. We can set the role as fabric control plane node and fabric border node. On the SDA fabric, we can set these 3 roles: fabric edge node, control plane node, and the border node. Okay, here. Once we have all the devices, once we have made the reachability between the devices, once we have made the reachability from the devices to the DNS center and everything, then what we are going to do, we are going to actually set the roles onto the devices. There are total 3 roles that we are going to set on these switches. And additionally, if your switch supports maybe embedded wireless LAN controller functionality, then we can set the wireless embedded WLC role onto the switch as well, or we can have a dedicated device for the same as well. So fabric edge node, fabric control plane node, fabric border node, and the fabric enabled wireless LAN controller. Fabric edge node is the place in your SDA design where the end users are going to be connected. Where these end users are going to be connected, like this switch, this switch, this switch, all these switches are set in fabric edge node role. Here is where your wireless access points are going to be connected. Here is where your those special switches are going to be connected that are designed, that are manufactured for those non-carpeted environment, IE series switches, for example. Catalyst digital building switches, for example. So the fabric edge node is the place where the wired users get connected to the network. Fabric edge node is the place where the access points get connected into the network. Fabric edge node is the role. Fabric edge node is the device where your these special switches, such as like industrial Ethernet switches and everything, they get connected into the network. Typically, you can compare this with the access layer devices. In a traditional network, we had this thing called access layer. Here, we have this same concept called fabric edge node. So fabric edge node provides connectivity for the wired endpoints and the access points to the SDA fabric. They are responsible. Okay, forget about the next line. Okay. Now, what happens whenever any of the device comes online? Let's say, for example, this device comes online and this device sends any traffic to this particular fabric edge node. The fabric edge node is responsible to register the information of this device. It is going to refer to as endpoint. It is what we are going to refer to as endpoint, and its IP address or the MAC address is going to be referred to as the ID. So this fabric edge node is responsible to register this endpoint ID, which is like, IP MAC address, somewhere in the network. It is responsible, this fabric edge node is responsible to register. The fabric edge node is responsible to register the endpoint that is what we have connected here in the network. It is responsible to register that endpoint information somewhere in the network. Let's call this endpoint as A. The fabric edge node is going to register somewhere in the network that the endpoint A is connected to me. I'm going to call that S1. Basically, this fabric edge node, when it detects that the endpoint is connected to it, it is going to register the information that this endpoint actually A is connected to me. In reality, both of them are going to be some IP address. Okay. Then what happened? On some other fabric edge node, and another endpoint comes online. So this fabric edge node is going to register this information that the endpoint B is connected on me, switch number 2. Okay. Similar to that, anytime any endpoint comes online, it is the responsibility of the fabric edge node. It is the responsibility of the fabric edge node actually to register this information somewhere in the network. Why? Because now when, let's say, for example, the device B wants to communicate with device A, packet will arrive onto this fabric edge node. The fabric edge node has no idea how to reach to that B. It has no idea of like the destination, no idea how to reach to A. It has no idea how to reach to A. It has no idea how to reach to the endpoint A. It will ask someone that, do you know how I can reach to A? That device will respond that, yes, I know how to reach to A. If you want to go to A, do one thing, go to switch number 1. So now this device will send, it will, forward all the traffic towards the switch number 1. And switch number 1 will receive it, and then it will hand over that traffic towards the other LAN other end user. Again, let's take more realistic example. This device has an IP address of 10.1.1.1. There is a loopback configured onto this switch with the IP address of 1.1.1. Here we have a device with the IP address of 10.1.2.1, and here we have a loopback configured with the IP address of 2.2.2. The device comes online, device sends some data, the switch is going to register the information. The switch is going to register this information that 10.1.1.1 is connected to 1.1.1.1. This device comes online, this device gets that information, this device detects that the device has come online and this is its IP address. The device is going to register this information that 10.1.2.1 is connected on me, 2.2.2.2. The place where this registration is done is what we refer to as control plane node. The control plane node in the Cisco SDA is actually where this registration is done. The control plane node in the Cisco SDA is the place where this registration is actually done. Registration of endpoint ID. Registration of the endpoint ID and its associated switch IP address. In technical term, it is what we refer to as endpoint ID. In technical term, we call this as RLOC. RLOC stands for routing locator, switch IP address in short. RLOC. RLOC is just IP address of the switch. RLOC stands for routing locator. So there is a device designated in our SDA deployment called control plane node. That control plane node is responsible to receive the endpoint registrations and maintain a sort of database. And now, let's say the traffic needs to go from 10.1.2.1 to 10.1.1.1. Traffic will arrive onto this switch. This switch actually has no idea how to reach to 10.1.1.1. So this device will ask the control plane node that tell me how can I reach to 10.1.1.1. The control plane node is going to check its database and it will say that if you want to go to 10.1.1.1, you need to go to 1.1.1. So now this device is going to forward all the traffic that it has received towards 1.1.1.1. And while forwarding the traffic towards 1.1.1, it is going to perform some extra encapsulation onto that particular data. When the traffic is received onto that 1.1, this extra encapsulation will be removed and the traffic will be sent towards 10.1.1.1. And the same process will repeat when the traffic goes from 10.1.1.1 to 10.1.1.2. Now read this line. It says, the fabric edge node are responsible for registering the endpoint ID that joins the network and encapsulates the traffic in the fabric network. And the control plane node provides a mapping system that manages the endpoint to device relationship. Like what endpoint is connected to what device, that relationship, that information is maintained on a node called control plane node. It is they are like an essential component of the SDA fabric, because without them, like your SDA fabric will not be able to operate. Control plane node has to be there. Consider it as if you are good enough with the traditional network, consider these as DMVPN hub. In the DMVPN hub, we have the information, if you remember, of the tunnel IP and its associated NDMA IP address. Here you can consider them the same. The control plane node maintains a database. In that database, it will include the information about the endpoint ID and its associated public IP address. It's associated its switch IP address, not a public IP address, switch IP address. why it is why it is done that, why they have done that, like we'll talk about that later in our network layer. But this is the role of the fabric edge node and the control plane. Okay, what is fabric edge node? What is fabric edge node? Fabric edge node provides first hop services for the users connected to the fabric, just like the access layer switch in the traditional network. Fabric edge nodes act as the default gateway for the end users. It is also responsible to perform. It is responsible to identify and authenticate the endpoint using techniques such as static authentication, .1x, Active Directory, whatever. When the end user is joining the network and we have set some sort of authentication, it is the responsibility of the fabric edge node to perform the authentication of the endpoints using like maybe .1x, Active Directory, user ID, password, or whatever. It is going to register the information that a particular endpoint, IP and MAC address is connected on me. This information it is going to register onto a device called control plane node. Control plane node will have the IP to RLock and MAC to RLock mapping, based on which it will be able to know that this IP has this MAC address. Register endpoint information to the control plane node. Perform encapsulation, decapsulation, decapsulation of the data when the traffic is sent and received onto the device. Whenever the traffic is sent out of the fabric edge node, it will be encapsulated. When the traffic is received on the fabric edge node, it will be decapsulated. Okay, fine. Now, one more thing, which is like, quite unique to this SDA. If we have, for example, 3 fabric edge node and we have 3 users there, all of these users, let's say, for example, belong to the same, let's say, VRF, same VN, we call that in terms of SDA VN, virtual network. Let's say, for example, we have created a VRF called Corp. In terms of SDA, we call that VN, virtual network. Let's say we have created a VN called Corp. In this VN Corp, we have our corporate users. So this is one interface that is going towards a corporate user, part of the VN Corp. An interface going towards the corporate user, part of the VN VRF Corp. Same here as well. All these devices will have, of course, a different IP address so that they can communicate to each other and the rest of the network completely fine. But for this device, this is acting as the gateway. For this device, this is acting as the gateway. For this device, this is acting as the gateway. On all these 3 switches, same IP address will actually be configured as the default gateway for this user, and for this user. The IP address of the default gateway remains same on all the fabric edge node for a particular VN, virtual network, or call that VRF. And that is why this kind of gateway implementation is what we refer to as any cast gateway. Yeah. Go ahead with the question. Berlin,
sir,
I cannot
before you.
I cannot hear you actually. If you are saying something, I think you are on unmute, so you're not audible actually.
It's audible now. No problem.
Oh yeah,
So
it is.
So these 3 fabric edges, right? They are all in different locations, right?
Could be on different locations. Yes.
So will there not be any issues if they use the same default gateway?
No. Think about it. Like, see, the gateway IP is only relevant to the same location, right?
Yes.
When we talk about even from the traditional network point of view, the default gateway IP address is completely like significant in the local broadcast domain only. When the traffic is received onto this fabric edge node, after that there is no use of that default gateway IP, because then the routing table and everything will be looked up to forward the packet toward the next devices. So they use this concept of anycast gateway, which says that the default gateway IP for a particular VRF, for a particular VN, will remain same across the entire SDA fabric.
So if default gateway is same, so the computers can also be same at both the locations, right? For example, 1.2.3.4, they can use at both the locations.
You can use it on both the location. Like, the point is that here, it is possible in this Cisco SDA that whatever subnet we have configured here, the same subnet is going to run here, the same subnet is going to run here. We can switch.
So here is my question. So 1.2.3.4 is the IP address of a computer that that exists in all these three locations.
No. I did not say that.
Okay.
I did not say that. I said that the gateway IP, gateway switch, gateway IP will remain same everywhere. The PC IP will remain different everywhere, of course. Like every device will have its own IP address. If they want to reach to any other destination, they will send the traffic to their respective gateway, and from there the traffic will exit there.
So which means the subnet can be different. The default gateway subnet can be different, and the computer subnet can be different, right?
No. You are not getting. See, the point is that this is a network. In this network, we have this device configured with the IP address of 1.2.3.4, right? So the default gateway that we have configured here is, let's say, 1.2.3.1, which is the IP address of the same subnet, right? Then we have same VRF on this device as well. This device will have a different IP, such as 1.2.3.5 maybe, but the default gateway will remain 1.2.3.1. Default gateway will remain same.
Okay, so the SDA itself ensures that the sites should not have same client IPs, right?
That because that is not ensured by the SDA. That is ensured by the DHCP server that we have in our SDA.
Okay.
Because if you are going to set the IP manually, then you have to make sure of that. But if you are using some DHCP servers to provide the IP to all the devices in my SDA deployment, then it is the responsibility of the DHCP server to allocate different IPs on all these devices, but the same gateway on all these devices.
Okay, got it. Understood.
Yeah. Yes, Srinivas. Yeah. You can let me know. Yeah.
Yeah, sir. Just you mentioned that all the EID will register to the control plane. What about if I have the two control plane? We have to make sure which one is the. If we have the two control plane,
we don't set any primary, secondary. Like if there are two control plane nodes, both will remain active.
Same, active.
Yeah,
okay, sir. Other question is for the endpoint. If I am using the DHCP, how long once the edge device will update the EID information to the? Does any particular time, or because DHCP
as soon as the edge node receives any information from this device, like any packet from this device, because this edge device must know that a particular IP and MAC address is connected onto the LAN side of it. So as soon as it receives it, it will register it. It will register.
Okay, if I restart the edge device, the same device will getting the different IP address. It will register to the control plane. That's correct, no?
Because the entries will have some time, right? Like the entries are not for undefined time period, so the entries might get wiped after some time. So somehow, like if the device has been removed, or if the device is still present onto that device, the information has to be updated on the control plane node as well.
Okay, sir. So we can manually refresh the RLOC logs or something like that. Because sometimes we can't ping that IP address for the end device.
We can check that. We can check with configuration commands, but logs will not. We can check with some configuration commands.
Not logs, sir. Just clear or refresh that forcefully update the EAD information to the RLOC server.
That we can check with the configuration commands.
Okay, but we can't force.
Not that I know of, actually.
Okay, sir. Because whenever we are restarting the edge device, we can't ping the EAD IP address. We have to shut down the port. We have to open the authentication, and then again we have to put the authentication back. Somehow the RLOC server doesn't have any information.
Switches, like you're talking about from this switch point of view, right?
Yeah, that switch I can ping internally because it's the same broadcast domain. From the control plane or from the Fusion network, I can't ping to the end device. So when we restarting the edge device,
that like when you have, if let's say for example, if you have restarted the device and until all the authentication and everything happens, like I think like you will not be allowed to ping from any external network to that particular end device, and your traffic will come to this fabric as node, and then it will get dropped, like it will until the proper authentication and everything happens onto this fabric as node from the end device point of view, the communication will not be allowed from the device.
Oh, okay, sir. Yeah. Thanks, sir.
Yeah.
Before we proceed, can you just review the slide one more time, from the beginning?
Which one? This slide? Same slide?
Same slide. Yeah, because you had so much discussion, so it's just a bit confusing. So it will make
no issues. So the point is the fabric as nodes, like this is like the place where we are going to connect our end users. We are going to connect our access points. Here we are going to cover. Here we are going to connect our those extended node, policy extended nodes. As soon as this fabric as node, as soon as the fabric as node detects a device, it is going to register its endpoint ID, which is IP address or MAC address, with its own IP address onto control plane node. This device detects that a device has come online. It is going to register its endpoint ID with its RLOC address. We call that RLOC towards the control plane node. Same thing will happen on here as well. Now, when the device, let's say, for example, this device needs to communicate with this device, packet will arrive on this fabric as node. The fabric edge node has no idea how to reach to this destination. It will ask the control plane node. Control plane node will check its database. It will inform the fabric as node that, oh, if you want to go to that 1.2.3.5, you need to go to 2.2.2.2. And then the fabric as node is going to perform some encapsulation on the data and send the traffic towards the fabric as node number 2. Here it will be decapsulated and sent towards the end user. And the same process will repeat in the reverse direction.
Why is it encapsulating it? What extra information is it adding?
VXLAN. That is why, like when the traffic arrives on this fabric as node and the traffic is sent towards the other fabric as node, that extra encapsulation that is being done from this fabric as node is that VXLAN information, okay, like the VXLAN tunnel and all. Because of some extra encapsulation will be done. Because of that, we get some extra functions such as, for example, same subnet can live on both the switches.
Understood. Thank you.
Okay, this is fabric as node. What devices are compatible with the fabric as node role? These are the devices compatible for the fabric as node role. No need to memorize it again. Just open this website, same website, just open SDA compatibility metric, go to the very top and select, instead of all role, select the fabric as node and submit, and you will get the result, what devices are compatible with the fabric as node role. 9200 series switch platform, 9300 series switch platform. We have 9400 series, 9500 series, IE switches, 3800, 3600. So the point is that here we can see like these are some switch platforms that are supported for the fabric as node. 92, 93, 94, 95, 96, 36, 50, 38, 50, 4500, 65, 68. Even in these, not all the models might be supported. Some models with a specific supervisor engine line card has to be there. You need to check it from the compatibility metrics. There are different models of, let's say, for example, 3650 series switch platform. Some came way before, some came way before, like the other one. So not everything is going to be supported. You need to check it from the SD compatibility metrics. What platforms are supported for the fabric as node?
Sir.
Yeah.
So is the SmartNet licensing comes under the SDA, and like how we can uh, like in large enterprise network, uh, what's how we can maintain that,
Maintain what exactly? Licenses?
yeah, licenses. Like suppose
Licenses
if
will
I
be
do
discussed
have,
later. Licenses will be discussed later on. Licenses we'll talk about later on. At the moment, we are just talking about the hardware that is required to build our physical infrastructure. We'll talk about the licenses later on. There are two types of licenses that get installed onto the device. One is like the base license, perpetual license, and then the DNA license. So we'll talk about the licenses later on. At the moment, just the devices that we need to use to build our SDA network. Fine. So how to enable a device for the SDA role? Very simple. How to enable the device with the SDA role? Let me show you on that same portal, same like Decode that we used earlier. I will go to the same Decode portal and let me show you how can we enable this role fabric edge node onto a device. Considering that we have built our network, we have made all the reachability and everything. If you want to enable the fabric edge node role onto the device, all you need to do is to just to go on that particular switch and just enable this checkbox. Right? Let me quickly show you.
So one doubt. So can we make suppose we have an edge node. So can we change that role to a border node or control plane node?
Not actually. Like if you once the role is set, if you want to reset the role, you have to remove the device from the fabric and set it again. And like, can you set multiple roles on the same device? Yes, you can, but you have to check it from the data sheet again if your device supports like more than one roles or not.
So the models differs based on the roles also, right? So for example, if I am purchasing a device
reverse.
capable,
Roles based on the model, not the models based on the roles. See, we have specific switch models where we can set the roles. So not all the roles are, can be set like on all the devices. So
okay.
like typically, for example, if you try to set like more than 2 roles, like on some devices, it will not be allowed to set like all the roles. In some devices, it will be allowed to set all the roles. So like based on the device models, we can set the roles onto the devices.
Okay. So if I am purchasing a switch that is capable of edge node, and there is also a possibility that I cannot make that switch as a border or a control plane mode, right?
If you, let's say for example, you are purchasing a switch that is, let's say, at least 9500 series switch, right? It can act as the edge node. It can actually act as the control plane node, as you can see here, right? And it can also actually act as the border node. In fact, almost all the switches you will notice are allowed to operate like in all the nodes, all the modes. Yeah.
Okay.
But
the ISR and ASR can act as a edge node, right? The routers.
No, ISR like the border nodes and the control plane node, not the edge nodes.
Okay.
Edge nodes like switches typically, like not the routers.
Okay, thank you.
Fine. So if you need to set the role, all you need to do is to just to go to the device, just go to that network device, and there you can set the roles directly. You just need to enable this checkbox and click on the add button, and it will set the role on there. Remember that once you have set the role, it will not allow you to remove the device role. You cannot set another role. You have to, if you want to set the another role, you need to remove this device from the fabric, and then you need to set the role again. Unfortunately, this is not opening up at the moment. I will try to open it again. It's just not loading up. Not sure what happened. I will try to open it on the the other browser. I'm trying it on the other browser meanwhile. But it is that easy to set the roles onto the devices. No configuration required. We don't need to do any configurations actually. Just open the device, just open your DNA center, go to the fabric, go to the provision, and there you can directly set the roles onto your particular device. No configurations required. And once you click on add button and deploy, the DNS center is going to push whatever configurations are necessary to set that role. Whatever configurations are necessary, DNS center is going to push that to the devices. Right. So for example, I will click on this DNS center. I will go to the provision. I will go to the SD-Access. I will go to the fabric. I'm basically redirecting. I'm going towards the particular switch fabric that we want to change in some geographical location. Maybe, for example, such as San Jose. For example, in this location, I have multiple devices and I want to set the roles onto those devices. Right. We'll do that from the scratch when we build a topology. But let's say, for example, this is the topology of the San Jose network. Right. So this is, let's say, for example, the topology of San Jose network. And you can see here, like EN stands for edge node. EX, like you can click on that. This is like extended node, like, EX extended node, like, So just click on that. For example, click on this EN button and you can just check this box up. And once you check it, like add, and just click on deploy button, and then it will push this deploy button and it will push the configurations onto that particular device. Whatever configurations are needed to make it as an edge node will be pushed onto that device. And let me show you one more thing. Here we have like these much number of edge devices, right? So edge node, edge node, edge node. We have multiple extended node, and all those things. Forget about it. Focus on these edge node, edge node, edge node, edge node, edge node. Okay. And this is transit control plane node. Forget about it. Click on this button, and here you can. Here you can like remove the device from the fabric as well. You can remove the device from the fabric and reset the role later on, because maybe, for example, we want to set some other things. Like we want to configure the border node on this device. Maybe we want to configure the control plane node on this device. It will not allow us to do that because the role is assigned. So you need to remove the device and then reconfigure the device. No, we are not interested in that. Just check this. Just check this. Where is that? Do you see the interfaces? Fabric, port channel, not the port channel, advisories here, details. It's actually not showing the IP address. This is the switch IP address, not interested in that. It is not showing us the lot of statements. What I'm trying to see here is the IP address of that SVI that we were talking about actually. There used to be like a, here. So you go under here and check this. See what happened. For the employees VN, for the employees VRF, this switch has configured some, VLAN here, and it has configured some IP address on here as well. The IP address belongs to 10.16.52 subnet. The name that we have for the VN, it looks like this itself. If I go on the another switch, let's say, for example, if I go on the next switch, actually, if I go on to the next switch, I will see the same actually thing there as well. Can you see here the SVI? It's not showing actually. But anyway, so if you go on to this device, let's say, for example, if you go to this edge node onto this device, you go to, let's say, for example, configuration, actually the same subnet IP, same exact IP will be configured on here as well. Same exact IP will be shown here as well. Can I run the command? Show IP int brief? No, it is not allowed. Anyway, like we are not able to validate that here. The IP is not being shown, but rest assured, like the IP address will exactly be the same for the VLAN 1021 on all the 4 fabric edge nodes, on all these 3 fabric edge nodes. Whatever IP is here for this particular VN the same IP will be there on this switch and this switch, and that will act as the gateway for the LAN, for the end users and all these extended nodes. Right? Actually, it used to show, actually, I think like they have put more restrictions on that, but it used to show here, like right on here, it used to show the IP address that is actually configured on that particular SPI. Just for the moment, rest assured that here, when we check the configurations of that particular VLAN 1021, the IP looks like from the subnet 10.16.52, and exact same IP actually is there on all the 3 nodes. So this is how we can set the device in the Fabric Edge node role. This is how we can remove the device from the Fabric Edge node role. That's it. Removed it, done. Click on this device again. Like, see, here now you can set the roles. So if you are setting it as the edge node, can we set the control plane node? Not allowed. We cannot just leave the things on edge node and we cannot do that. Not allowed. Can we enable it only at the control plane node? Yes, it is allowed. Can we set it for both control plane and border node? Yes, it is allowed. No problem. Can we set it like edge node and the border node? Yes, it is allowed. No problem. Is it allowed to set all the roles? Doesn't look like it is allowed to set all the roles. So again, the point remains the same. You can choose like what role you want to assign to this particular device. As soon as you select that role, click on deploy button. DNS Center is going to push all the necessary configuration onto that particular device that will make it the Fabric Edge node. This is how we set actually the roles onto the devices. Right? This is the Fabric Edge node. Okay, fine. Next is Fabric Control Plane node, which we will talk about after some break. So control plane node in our SDA Fabric, it keeps a database. It runs a host tracking database. It basically maps the location information. The control plane node has a database. The control plane node has a database. That database is going to map the endpoint ID to RLOC mapping. So this RLOC is also referred to as the location routing locator. Eventually, basically, this is the IP address of the switch where that endpoint is actually connected. So a simple host database that maps the endpoint ID to the current location, along with some other attributes as well. When we use the configuration command, we'll be able to verify that. A host database supports multiple type of endpoint lookup, such as IPv4, IPv6, MAC. So IP to RLOC mapping, MAC to RLOC mapping, IPv6 to RLOC mapping, all those things will be there. It is going to receive, this control plane node is going to receive the registration requests from the Fabric Edge node and also something called a border node. From the border node as well, this control plane node is going to receive the registration request messages. Receives endpoint ID to map registration request from the control plane, from the Fabric Edge node and from the border node. For the known IP prefixes, all the prefixes that are known to our destination, all the prefixes that are known to our implementation, those will be registered on the control plane node by the border node and by the Fabric Edge node. And when the Fabric Edge node asks the control plane node about the RLOC of a particular IP, it is the responsibility of the control plane node to give the information to that particular device. So it resolves the lookup request from the edge node border node to locate the destination endpoint. So the Fabric Control Plane node is responsible to propagate. Fabric Control Plane node is responsible to propagate the information. It is responsible to send the information that this endpoint actually lives onto this particular router to the Fabric Edge device. What are the platforms supported for the control plane node? Again, go to the compatibility matrix and check what platforms are supported for the control plane node. Just go to the website, and there, instead of looking for now edge node, just go for the control plane node. Remember that the same devices that we can use for the control plane node can be used for the border node as well. So select it, submit, and it will list all the devices that are supported for the control plane node and the border node. There are routers and switches both available on this role. We can have a router running on as the control plane node. We can have a switch running as a control plane node and also border node. How to set the control plane node functionality? Same thing. Just visit just go to that portal. Just visit that page here. And let's say, for example, we want to set the control plane node onto the device. Just click on the device. It is an ISR 4400 series router, for example. Just click on that device and set the control plane node. And just click on add button. That's it. Add, deploy, and it is going to set. The DNS center is going to push all the necessary configuration that is going to mark this device as the control plane node. Nothing extra. Just visit the GUI. Just go to the GUI, graphical user interface of your DNAC, and just set the role on there. Whatever configurations are needed to be pushed, they will be pushed onto the device from the DNS center itself.
Sir.
Yeah.
Do we need to create the template in order to have the standard configuration to be pushed, or it will take automatically from the other switches and only change the IPs and it will push
make the reachability. Do you have to do the configurations on the switches, configure the protocols to make the reachability? That's it. No extra configurations required.
Okay, but in order to push the configuration, like production configuration, we need to have or the template kind of thing, right? So
templates and everything is completely different thing. Like, we can push the configurations with the help of the template that will be discussed later on. But if you are not push the templates or anything, still it will work. As long as you have set the reachability, as long as the reachability is there from the device to the DNS center will be able to push the configurations on there. At the moment, we are just talking about the role. We are not talking about anything extra, like the templates or anything other.
Okay.
Fine. Again, we can have multiple control plane node. Just go on there, enable the control plane node, deploy. Like I said, you will be able to do quite a lot of things on this Decode lab. So I would encourage you to, explore this Decode Cisco and then try to set the rules as well.
Is it open lab, sir?
Yes, I have it. Yes. Refer to the last recording of the last day. I have explained it there. How to access this lab. It is already explained there.
Okay.
Yeah. You don't need to book any lab for the same. It is it is instant demo. It's not a scheduled one. So you can just log in and just start doing the things. Okay. Now, the final role that we have in our SDA that we can set on the switches is called fabric border node. The last thing that we have here is called fabric border node. Fabric border node that we have in our SDA deployment, they are going to allow non-SDA devices to connect with our SDA devices. For example, here we can have, let's say, for example, a data center running on traditional network, maybe some public networks such as internet, cloud, public clouds and everything, data center, headquarters and all. They are advertising certain prefixes onto here. Here we are also receiving some sort of default route and everything. So these border nodes, these devices that we have set on the border node role, these devices are going to facilitate the communication from outside the SDA to inside the SDA and vice versa, from inside SDA to outside SDA. With the help of the border node, actually, the communication between SDA and non-SDA devices are, supported. Okay, Fine. Now, there are 3 types of border nodes that we can set. What is the border node? The border node, fabric border node, connects our SDA fabric to outside network or non-SDA network. It is the entry and exit point of the data traffic going in and out of the SDA fabric. Makes sense, okay? There are 2 types of network where we can connect. We can connect to our known destinations, such as, for example, headquarter, data center, branches, all these locations. And then unknown networks, such as, for example, internet, public cloud, AWS, Azure, and all those things. So there are 2 types of outside network that we want our SDA network to connect. We can have like a known network. We can have an unknown network. Known network such as a data center or a traditional branch. Unknown network such as internet or some public cloud. Now, how are we going to connect to these known and unknown destinations outside our SDA? How have we configured our border node to connect to these external destinations, external known and unknown destinations? Based on that, this device can either connect to only known destinations, unknown destinations, both of reachability and everything is completely on us. How have we made the reachability? Maybe we have a dedicated border node. Maybe we have a dedicated border node that is connecting to just external known destinations such as data center headquarter. Then we have, for example, a border node that is connecting to outside networks such as, for example, unknown destinations such as, for example, public networks such as, for example, internet or the, let's say, this public cloud. Yeah, public cloud. There are 3 types of border nodes. There are 3 types of border node. One border node that we have is called internal border node. One border node that we have is called external border node. And one type of border node we have called anywhere border node. So we can have a dedicated device, that connects only to the known destinations outside the SDA, such as our data center headquarters and all. This type of device is what we refer to as internal border node. Internal border node is the device that connects our SDA network to outside the SDA network. A dedicated border node that connects our SDA network to outside the SDA network, but that is not under our control, unknown network, such as, for example, internet, public cloud. So that kind of device is what we refer to as external border node. Okay. And if we have connected a device in such a way, if we have configured this border node in such a way that it connects to both known and unknown destination, then it is going to be referred to as anywhere border node. Not necessary to have 2 different border nodes for 2 different roles. Not needed. We can have like one, for example, border node for both the roles as well. Now, how do we configure it? What is the difference between, first of all 3 border nodes? How they operate, if we have configured a border device to be the internal border node, how it is going to operate with the other one. Okay, let's talk about that. Internal border node, first of all. First thing first, the internal border node. The internal border node connects our SDA network. The internal border node connects our SDA network to outside the SDA network, but that is under the outside network is known to us. It is like data center, branch office. So what will happen? This data center and the branch offices, they are going to announce all of their prefixes here onto our branch on a router. This router is going to connect to this border node here. And this router is basically going to perform that handoff of these prefixes into the SDA. Like, so let's say subnet A, B, and C, X, Y, and Z. These subnets were learned onto this particular router. The router has advertised those subnets to the border node. Border node has the IP address of 1.1.1.1. This border node is going to register all these prefixes to the control plane. It is going to register that if you want to go to A, B, C, X, Y, Z, you can come to me. Internal border node imports, they register these external subnets to the control plane node. These are all known destinations outside our SDA. These are all known destinations. The internal border node is going to learn all these subnets and it is going to register them to the control plane. So the control plane node actually knows that if I want to go to ABC, XYZ, this is where exactly I need to go. It is going to import and register known IP subnets from outside into the control plane mapping system, except the default route. Except for the default route, it is going to import and do all the things. Also, this border node is going to export all of my SDA subnets 1, 2, 3. It is going to export all the SDA subnet 1, 2, 3 towards this router. This router is going to advertise those subnets to the data center and those branches so that they know that these subnets actually live in somewhere in the remote location. For this purpose, for this exporting purpose, what protocol are going to be used? Like this, from this border node to this router, we will use some protocol to export all these subnet like 1, 2, 3 subnet towards the traditional data center branches, these location. We can use any traditional protocol for the same, as long as that protocol is supported, as long as that protocol supports VRF. It's okay. Like, as long as that protocol has the support for the VRF, we can use any protocol. However, in reality, the protocol that we will use is the BGP, is the border gateway protocol. The protocol that will be used here on the border node and this router responsible to accept all the routes from there, advertise all the route to there, is going to be the BGP protocol. It is going to be border gateway protocol. So internal border node connects to any known destinations outside the SDA network, such as, for example, data center, firewalls, wireless LAN controller, branches, and all these devices. It is going to export all the internal IP addresses to the outside using some traditional IP routing methods, not the VXLAN, not the Lisp. And it is going to import and register all the outside subnets like XYZ 1, 2, 3. It is going to import and register all the outside subnets towards the control plane node as well. It imports and registers known IP subnets from outside into the control plane mapping system, except for the default route. And we also have like the handoff between like the traditional and the SDA might also require like VRF and SGT mappings from one SDA domain to, let's say, for example, non-SDA domain as well. We might also need to hand off like, not only the VRF, but we might also need to hand off the scalable group tags and some other parameters as well. It is the responsibility of the border node to also advertise, let's say, things such as, for example, scalable group tags and everything as well. Now, external border nodes that connect to outside unknown destinations, they are not going to. This is an unknown destination, such as, for example, internet or a public cloud. So I am going to learn maybe all these prefixes on this router, or if not, then I will just have a default route. Who cares, like, to learn all the routes? If you have like all the routes, then it's okay, no problem. But like, of course, you might not have like all the possible routes to reach out to all the destinations on the internet. So that's the default route will be fine. But even if, let's say this router is receiving all the routes from the outside network, and the routes are getting advertised to this device, this border node, it is not going to import, it will not import external routes into the SDA domain. This external border node, outside world, or the external border node is gateway of last resort for these devices to reach out to any unknown destinations. Default route. It connects our SDA network to outside SDA network that is not under our control. Some unknown destinations such as, for example, public cloud or the internet. It is going to export all the routes. This device is going to learn all these routes. It is going to export all these routes to the router, but it is not going to import any route from the outside to the SDA network. It will just be used as the default gateway for the SDA devices. Nothing more than that. It does not import any routes. It is used as the default route. If exact route is not available, then this will be used as the default route to reach out the external destinations. Questions? Let me know. Doubts? You are not audible again, Berlin. You check the mic once.
No, we cannot hear him either.
Okay. Remove the mic. Remove the mic. Like, you know, if you're using any headsets, remove it. Like sometimes that fixes the problem.
I had to switch mics. I have multiple mics, so I switched between them and then it started.
Yeah, might be the issue. You can use the chat box if it's. I'm still not able to hear you, Berlin. If still the problem is there, you can use the chat box for the question. Meanwhile,
so it seems that the only difference between internal and external is the default route. In the internal one, you will not have a default route, and in the external one, that it is the default route.
Also, the difference is that the external border node is not going to import any outside prefixes into the SDA.
Exactly. Yeah.
And it is still going to import, like it is going to still export all these prefixes of the SDA to outside, but it is not going to import any out because too many prefixes of the outside destinations.
Indeed.
Am I audible now?
Yes, you are audible. Yeah,
yes.
Now so.
So there will be two border nodes, internal and external. So the external will be providing default route to the SDA infrastructure, right?
Yes. Yes.
And you have also mentioned that it doesn't import any routes from the SDA infra. Is that right?
From like in the HCNs, like it is not going to import any external routes from outside in the SDA.
Okay.
Like I am still like, say, this is my one of the subnet, this is the second subnet, this is the third subnet, A, B, and C. I am going to advertise the subnet information towards I am going to export these subnets towards the traditional network, but I am not going to import any outside subnet into the SDA.
I got it. Yeah.
Yeah. And
what is that SGT?
SGT is scalable group tags, based on which we can configure the policies for our endpoint users. The ICE, it is a part of ICE. We'll talk about that later on when we talk about ICE.
Okay, thank you.
One more thing I would like to say here. It is like, see, here also, right here also, even though this actually border node connects to our known destinations such as data center and branches, is it actually mandatory that I want to learn all these prefixes as it is here? Not exactly. If I want, see the subnet A, subnet B, subnet C, X, Y, Z, I am learning all these prefixes, but I am not going to import these prefixes into the SDA. Because anyway, I'm going to be, I can configure this as the external border node for even our known external destinations as well. As long as that device can be used as the gateway of last resort, every traffic will reach out to this device, and this device already has that information, so packet will still be forwarded, no problems at all. Like what I'm trying to say, this doesn't matter. What I'm trying to say, this does not matter. Actually, what matters is like what type of border node we have configured here. If it is configured to be an internal border node, then it will learn and register all the external networks into the SDA, so that this control plane node knows that if I want to go to ABC, XYZ, here is where I have to go. And if we have configured it as an external border node, then how does that, even if we have configured it as an external border node, this device is not going to, it will have all the information. This border node will have all the subnets. It will just not import it into the SDA network. But since this device is configured as an external border node, it is being used as the gateway of last resort. Everyone can still use that device to reach out to these external destinations. So the only point that matters is that, are you going to import are you willing to, do you want to import the external routes into the SDA or not? If you want to, configure it as an internal border node. If you don't want to, configure it as an external border node. And the best, I would say, do both. Like, you want this device to actually import all the external routes as well as become the gateway of last resort. So configure it as the anywhere border node. Typically beneficial in the situations when the connections get terminated, where we have like a single border node and the connection is getting terminated from the router going towards our traditional network and the internet as well. So I will learn all these like DC HQ prefixes. I will register them to the control plane node, and I am also going to act as the default gateway so that the traffic can also reach to the internet. Anywhere border node or internal plus external border node is one all exit point for any known and unknown destination. It connects to the unknown IP destinations outside the SDA fabric and to the known destinations such as DC. It is going to import and register all the known subnets from the known network, and it is also going to export all these SDA prefixes to outside network. Also, this will act as the gateway of last resort. How can we set it now? Same thing. Let's say that this is our border node, right? Let's say this is our border node. Let's say this is our border node. So I think I need to, okay, anyway. So when you configure this border node has to be configured. You will need to configure the border node. Remember, control plane node, no need to configure. Edge node, no need to configure. Configure by mean configurations. We don't need to do any configurations, but when it comes to the border node, we need to do the configurations regarding import and export. This is the border node. This is our fabric border node. It is going to receive the prefixes from the traditional network and import it into the SDA. Receive the prefixes from the SDA and export it into the traditional network. Here on this border node, we will need to do the configurations. So if I remove this device from the fabric and I reset it, I try to configure it again, you will need to configure it. Like, you click on this device, maybe this device is our border node. It is receiving the routes from our routers maybe. I will click on this device and then as soon as I check on this box, it will ask me to configure it. Right here, we have that concept of handoff from traditional to the SDA, from the layer, from the layer 3 point of view, like the routes from the SDA are going to be exported into the traditional and the traditional to the SDA. That handoff is what we refer to as the layer 3 handoff. And this border node can also be used to hand off the VLANs. So let's say we were migrating from the traditional to the SDA, right? And the migration like of some branches is being done. Now, the problem is that a few users, like a few switches have been migrated into the SDA, and those switches now, on those switches, we have some users. This is a switch that has been migrated into the SDA, and it has a few users in a corporate VM. And for this corporate VM, the switch we have configured, not we actually, DNS Center has configured an SVI called 1024, maybe, any random number. The problem is that the same corporate user also exists in a traditional network because the migration is still going on. It will take a few more days to complete. So meanwhile, the same corporate users are also hanging around in the traditional network. They have the same subnet, 10.1 subnet here, 10.1 subnet here. But the problem is that here we have our gateway is like, for example, this switch here, our gateway is on this switch here, we have a different VLAN configured here, we have a different VLAN configured. So when the migration is happening, actually, you might also require to perform this thing called layer 2 handoff. In the layer 2 handoff, what we do actually, while doing the migration, if some traditional users are still part of the traditional VLAN, such as 100, 200, and in some places we have deployed this, SDA and all, so that at that time of migration, actually, at that time of migration, we might want to map the SDA VLAN with the traditional VLAN, so that the devices in the SDA can understand that, oh, we are still talking about the same corporate user. So that is done on this layer 2 handoff. In the layer 2 handoff, what we do actually, we map the traditional VLAN with the, we map the SDA VLAN with the traditional VLAN. And we tell that, okay, this is the interface of our border node going towards the traditional switch. We'll talk about that later on. But the point is that 2 types of handoff we need to do. One is called layer 3 handoff, one is called layer 2 handoff. Layer 3 handoff typically deals with the routes, and layer 2 handoff typically deals with the VLANs. In the layer 3 handoff, when we enable the layer 3 handoff, right here, actually, we can set if this device is a internal border node, external border node, or anywhere border node. So see very carefully. If, for example, while setting the role, I have not enabled any check here. I have not enabled any check. No checks here. So it means it is internal border node. Internal border node means like this device is going to learn all the prefixes, import it into the SDA. It is going to learn all the prefixes and export it outside the SDA. This means internal border node. If we have not checked, if you have not enabled any checkbox here, it will be known as the internal border node. If I click on this button, if I checkbox this and I check on this one, it is what we refer to as external border node. What do we mean by that? It means that this device will act as the default gateway and it will not import any external route. It is the property of the external border node. So see, if you mouse over it, it says this is the gateway of last resort. Any unknown traffic will be sent to this fabric border from the S device. After the node role is configured, you cannot change the border type. Then if you check on this one, check this box if you do not want to import the external routes from the other routing protocol, such as BGP, to the control plane node. So if you have checked these 2 boxes, it will be like external border node. And if you have checked this box only, and if you have not checked this box, then what we say, it is called anywhere border node, because it will import the external route as well as it will act as the gateway of last resort. See here, right here.
Yeah. So on the anywhere border node, how will it know which are internal routes that needs to go into the control level?
Okay. So for example, okay. So in this topology, where is that? In this topology, let's say, for example, these devices I have configured as this device I have configured as anywhere border node. So this device is connected to, let's say, this router, which is going towards the internet. And here we are connected to the router that is going towards our data center headquarter and all. So obviously, like this data center headquarter and all these locations, they are going to announce a few prefixes. Those prefixes will be received by this our site edge router, and the site edge router is going to advertise those prefixes to this particular router. Those prefixes that I have received from my site edge router on this border node, and I have registered those prefixes on here. I have said to go to A, to go to B, to go to C. Where we had to go? We had to go to like 1.1.1.1. Also, this router maybe is receiving a default route from here so that it can reach out to the internet. And I want that this router, this device should be reused as the gateway of last resort. So we have checked that box of external node as well. So it basically means that this device right here is also going to be acting as the gateway of last resort. So now let's say any end user tries to reach to B. Packet will arrive on the Fabric edge node. Fabric edge node has no idea how to go to B. It will ask the control plane node how to go to B. B will say go to 1.1.1.1. Okay, so when the reply comes, this Fabric edge node will redirect all the traffic to the border node. And from the border node, the traffic will reach here because I have the route. If from here, the traffic has to go to, let's say, for example, 8.8.8.8, packet arrives on the Fabric edge node. Fabric edge node asks the control plane node, how can I go there? Control plane node says, I don't have any entry about the same. I don't have any entry. But do one thing, go to this 1.1.1.1. I don't have any entry regarding the same. Negative reply. We'll talk about the technical term later on. The Fabric control plane node has said, I don't know how to go there. But do one thing, here is our, as per the configurations done by the administrator, this device is being used as the external border node. So do one thing, send all of your traffic to the Fabric border node. And as a result, this device is going to again redirect the traffic to here. And on here, since we have a default route, using that, it will be redirected to here. So to answer your question, there is no way that these devices will know that if they are trying to reach to the internal or the external networks. If they get the positive reply from here, then also the traffic will reach here. If they get the negative reply, then also the traffic will reach here. And eventually it is on the border node to redirect the traffic here or here.
Okay, thank you. My next question is about the control control plane. How many control
nodes we can have in the network?
Yeah, how many nodes should we have, and how should we distribute them in our infrastructure?
At least, like, it is recommended that when we talk about a site, it is dependent on the Fabric site actually. So it is recommended that at least one control plane node has to be there in one Fabric site. For the redundancy purpose, have at least two. Right. So for example, like we are going to organize our entire network that we have configured all around the world. This is, let's say, site number 1. This is site number 2, site number 3. It is recommended, like here, at least one control plane node, at least one control plane node, at least one control plane node you have. And for the redundancy purpose, it is recommended to have 2. We can have more than 2 as well, but at least 1. And for the redundancy purpose, it is recommended to have 2. A site configuration, a Fabric site is incomplete without this control plane. You will need to have the control plane node on the particular device. So it is based on the Fabric site rather than, based on like the entire location.
Right. So each location should have a control plane node.
At least one, yes, definitely.
At least one. Okay.
Yeah.
And let's assume we have some sites with one control plane nodes, and we have some sites with 2 control plane nodes. And the site with one control plane node, that control plane goes down, so it can reach out to any other control plane nodes from another location.
No. That will not happen.
Right.
That will not happen. There comes a concept of a transit. Like, when we talk about connecting 2 or more branches together, there comes a concept of transit. And the transit can be an SDA transit can be an IP transit. So that thing will again be dependent on the configurations that we have done onto those devices, onto the branches. But if short answer, by default, no. We have to at least for the redundancy purpose, at least have like at least 2 control plane nodes on the particular site for redundancy high availability. So here, like, for example, in this diagram, if you go on in this diagram, like, for example, here they have created a lot of sites. You go to the design, you go to network hierarchy, and you can see that here in this vCloud, they have configured like a lot of branches and a lot of sites, let's say here. So on every site, we will have, like, for example, Asia, Egypt, South Africa, North America, USA, California, Texas, Washington, New York. Like, the point is that in all these locations, this is a site. In this site, we have a Fabric. In a Fabric, we will have in this San Jose Fabric right here, we will have a set of control plane node, border node, and the edge node for a proper Fabric operation. So you can check that from, like, by going to the provision. SDA sites. Right here, we create our fabric, and we can go to any any of the site that we have here, and we can notice that it will also give you a prompt. It will also give you some sort of warning that the device, that the particular site is not having any control plane node, border node, or something like that. So it will also give you some sort of prompt on there. Okay, fine. So we will need to have at least one control plane node, border node, and the fabric as node, so that these things can be facilitated. And there are some switch models. There are some switch models where all the roles can be set on the same box as well, which is what we refer to as fabric in a box. Fabric in a box is a feature. If it is available onto your Catalyst switch platform, it will allow you to set all the roles on the same device itself. It will allow you to set all the roles on the same device itself. Like we can set the control plane node, border node, and the edge node all on the same device. It is very beneficial in a small deployment. Like if you have like a small deployment, there we can a few routers, a few users are there, and we want to actually set, for example, some roles on the devices. The fabric in a box feature allows like us to set all the roles on the same switch without the need of having more than one switch in the site. So in a small to very small deployment, actually, like it is not, it is like where the number of users are very less, number of devices are very less. There, this feature is actually very suitable. So like on the same box, we are going to co-locate the control plane node function, border node functions, and the edge node function. Catalyst, for example, 9303 switch supports that kind of deployment. A dedicated control plane node, a dedicated border node is very much beneficial in a medium to large scale environment, as it can improve the network stability for during like both fabric site change management and even in the event that the fabric device becomes unavailable in the network. So we have like multiple control plane node, we have multiple border node. If one device becomes unavailable, the other device is available to take the responsibilities. Like we have a dedicated device for the control plane node, we have a dedicated device for the border node, and we have a dedicated device for the fabric as node. And this kind of deployment is very common in a medium to large scale network. But in a small scale, small to very small site where the number of users are very less, we can go for fabric in a box feature. We can enable all the functions, control plane node, border node, edge node. We can enable all the functions on the same device. Also, side by side, we can also enable the embedded WLC, embedded wireless LAN controller. We can enable the embedded wireless LAN controller. We can also enable like WLC functions on there as well. Embedded wireless LAN controller can be enabled on there. Dual fabric in a box means like two devices we have placed, and on both the devices we have configured the fabric in a box feature. However, it should be used if mandated by the existing wiring infrastructure. We can have like dual fabric in a box feature, like 293 switches in a small location, and we have set all the roles on all the devices, on both the devices basically. So dual fabric in a box feature is also supported. You need to check the documentation. You need to go through the data sheet and find out if, for example, your device actually supports the fabric in a box feature or not. Not all the platforms support it, so you need to check it from the data sheet. I believe that here, not sure, do we have any, let me see, device where they have enabled like all the roles at once. So if I go on here and set the control plane node, border node, and the fabric border node, like here, we need to set the parameters for the handoff and everything. right? Once we have set all these things, see, it is allowing us to set all the roles on the same box. So it is possible, it is allowed. Not all the platforms support, such as 3650, 3850 does not support that. So you have to be very careful. Like you have to check the data sheet, before you purchase a switch for a small or a very small location. And there, if you want to use that fabric in a box feature, first of all, you need to check the data sheet for the support of that particular feature.
And I can see we can enable wireless LAN controller here as well.
Likewise, we can also enable here, right here itself. We can enable the fabric enabled wireless LAN controller. Of course, like we need to download the WLC image, install it on the device, then do some configuration regarding netconf and all that. But yeah, it is completely possible that we enable the fabric WLC functionalities on the same box as well.
And we are going to touch a little bit of wireless in this training.
Definitely. I will show you how to onboard a wireless LAN controller in the SDA. And for that, I will be using the PNP process.
Okay.
So if the access point is in fabric, so similar to the wired devices, so the MAC address or the device ID will be sent using access point.
Yes. Access point, like not the AP one. The AP, let's say for example, the access point is connected on the fabric as node. And a user connects onto that AP, right? That user information will be given to the fabric. Of course, the AP will be. You can also check the things of the AP on the WLC as well. That is on the DNS center as well. That is fine. But the client information is going to be sent from the access point towards that particular fabric as node, and from the fabric as node towards the upper DNS center control plane node.
Okay.
So we can see, I'm not saying that we cannot check the information about the AP. We can do that. We can go to the assurance. We can go to, let's say, for example, health, and we can check, for example, network. We can check the number of network devices right from here, and we can see right here. So see, we have like a few routers, core switches, distribution layer switches, access layer, and right here we can see the APs. Click on the APs. There are 42 APs that are basically SDA capable APs. So those can be checked and managed from here itself. WLCs can be checked and managed from here itself. But when it comes to registration, when the client gets connected itself, the client connects itself onto the access point. The access point is going to learn its information, and that will get registered on the control plane node. It is also going to, the access point is going to inform the WLC about the same. WLC is also going to register it onto the control plane node. We'll talk about that in detail in the wireless section at the very end, but that is completely possible. That is completely possible. See here, AP. These are the access points that are there. Click on any access point, such as, for example, this. You will get a detailed information about that AP, as good as a dedicated, monitoring software here. All the issues and everything, all the events that have happened, things you can check from here as well. What are the users? What is the AP name? CPU utilization, uptime, and everything. So these are all the physical devices that we have here in our SDA infrastructure. These are the different types of devices and roles. Basically, this is it. This is it about all these physical layer in the SDA infrastructure. Next thing is that, okay, now we have all the devices. We are setting the roles and everything. That is completely fine. Now we will talk about the protocols that will be used in this entire process. Like, for example, just to give you a brief idea, when this device comes up and this fabric as node registers this information to the control plane node, it is going to use a protocol called LISP, Locator ID Separation Protocol. When this particular device tries to send some traffic to here, this fabric as node has no idea about the same. It will ask the control plane node, how can I go to that destination? It will also ask it via LISP. The control plane node will tell that, okay, if you want to go to that destination A, you can go to 1.1.1.1. That it will also do it via LISP. And when the traffic is needed, this is all control plane operation. So we can say that the control plane is built around Lisp technology in our SDA. And when the data traffic has to pass, the data traffic has to be encapsulated as well. And that encapsulation will be done from the S device to S device with the help of a technology called VXLAN. So at the data plane, we use the VXLAN. At the control plane, we use the Lisp protocol. And when it comes to enforcing the policies and everything, we are going to use CTS, Cisco Trust Sec. This is all going to be covered in our next layer. These are the platforms for the border node. You can, again, same thing. You can check the compatibility matrix for the same. And all these things are going to be like from the Lisp, from the VXLAN, from the Cisco Trust Sec point of view, all the things will be covered in our next layer, which is what we refer to as the network layer. So here we will talk about the underlay, overlay, fabric, roles, protocols, VXLAN, Lisp, ISIS, all these things from the underlay, overlay point of view, we will talk about in our next class. Meanwhile, for today, we are going to do only this much. If you guys have any question, you can discuss. And we will continue from here, like in our next class, next week. We will talk about, just go through like chapter number 1, chapter number 2 of your official book, and to get a better understanding of all these things, and try to cover everything up to like these rules, like what type of rules we can set onto the devices. Try to do try to set some rules from this Decode website from here itself. Later on, when we do the lab, you will be able to get like all those things in much more clear way. Then in the next week, we will start with our fabric second layer of the SDA architecture, that is the network layer, where we'll talk about fabric underlay, overlay, and the fabric network itself.